Tonight, we drift into the quiet mysteries of the universe. You don't need to follow every word, just let the story carry you, like starlight across a calm sky. As your breathing slows and your mind begins to settle, we'll explore together the gentle wonder of dimensions beyond our perception. The universe is whispering its secrets tonight, and we'll listen without urgency, without demand. Let the soft current of ideas carry you wherever is most comfortable, whether toward deeper contemplation or peaceful rest. The evening air feels different when we pause to truly notice it. As darkness settles around us, the familiar shapes of day transform into something more mysterious, more open to possibility. The shadows create depth where there was once only flatness, revealing how our perception shifts with the changing light. Much like these shadows, our understanding of reality contains depths we're only beginning to comprehend. The world we know so confidently in daylight becomes something more elusive as night unfolds. We drift beyond the surface of 3 dimensions, wondering if unseen layers cradle our existence. Consider for a moment the space around you, the height of the ceiling above, the width of the walls, the length from where you rest to the farthest corner. These 3 dimensions define our physical experience, creating the boundaries within which we move. Length, width, height, the cardinal directions of our reality. We navigate through them without thought, intuitively understanding their possibilities and limitations. We reach for objects, knowing exactly how far to extend our arm. We walk through doorways, instinctively gauging the space needed for our bodies to pass through. This 3-dimensional navigation has become so natural we rarely pause to consider it. But what if these familiar dimensions are merely the beginning? What if our 3-dimensional perception is like a shadow cast by something more complex, more complete? A shadow on a wall captures the outline of an object, but misses its depth, its texture, its full reality. Perhaps our experience of 3 dimensions similarly captures only a portion of a deeper reality. A reality that extends in directions we cannot point to, cannot name, yet mathematics suggests might exist. They speak of these higher dimensions not with the certainty of direct observation, but with the poetry of mathematics, equations, that suggest spaces we cannot visualize, yet somehow exist within the language of numbers. The mathematics of these higher dimensions is not merely abstract theory, but offers potential explanations for mysteries in our observable universe. Imagine holding a perfectly flat piece of paper, a 2-dimensional world. If a 3-dimensional sphere were to pass through this paper world, the inhabitants would not see the sphere in its entirety. They would witness only a circle appearing, growing, then shrinking before disappearing entirely. A mysterious event from their perspective, yet perfectly natural from ours. Perhaps we too experience higher dimensional events as mysterious phenomena, their true nature hidden by the limitations of our perception. The night sky offers endless opportunities for such contemplation. As stars glimmer against the darkness, each one a sun burning millions or billions of miles away, we're reminded of the vastness of just the 3 dimensions we can perceive. The distance to even our nearest stellar neighbor is nearly impossible to truly comprehend. And yet, these immense distances might be merely the visible aspect of a reality that extends in directions we cannot point to, cannot name, yet mathematics suggests might exist in the quiet of night. When the world has slowed its hurried pace, we can feel something of these hidden dimensions, not through our physical senses, but through the questions that arise when we allow our minds to wander beyond the boundaries of certainty. What lies beyond the edge of our universe? Where do thoughts reside before we think them? How is it that mathematics, a creation of human minds, so perfectly describes the physical world? These questions hint at connections between our reality and something more fundamental, something that perhaps exists in higher dimensions of being. The fabric of reality bends softly, whispering secrets of hidden corridors beyond length, width, and height. Einstein showed us that space and time are woven together, that gravity is not a force pulling between objects, but rather the curvature of space-time itself. Massive objects like our sun create depressions in this fabric, causing planets to orbit along these curved paths. If our familiar four dimensions of space-time can bend and warp, might there not be additional dimensions, curled up perhaps at scales too small for us to detect, influencing the nature of reality in ways we're only beginning to understand? When a gentle breeze brushes against your skin, you're feeling the movement of air molecules, invisible to the naked eye, yet undeniably real. Similarly, these higher dimensions might be imperceptible to our senses, yet manifesting their presence through subtle effects on our observable world. The mathematics of string theory suggests that there might be 6, 7, or even more dimensions beyond our familiar 3 spatial dimensions and 1 time dimension. Most of these dimensions would be compacted, curled up into spaces smaller than atoms, invisible to our instruments, yet essential to the mathematics that describes our world. Think of how a garden hose appears from a distance. From far away, it looks like a one-dimensional line. Coming closer, you see it has a second dimension, its circular width. Only by examining it very closely would you discover the third dimension, the hollow interior running through its length. In a similar way, what appears to us as points in space might, at incredibly tiny scales, reveal extra dimensions curled up into complex geometrical shapes. As you rest and listen, imagine for a moment what it might mean to experience even one additional dimension. We who live in 3 dimensions can move in 6 directions, up and down, left and right, forward and backward. A being capable of perceiving and moving through a 4th spatial dimension could seemingly appear or disappear from our perspective, entering our 3-dimensional space from a direction we cannot comprehend, then leaving just as mysteriously. Consider the simple example of a 2-dimensional being living on the surface of a piece of paper. If you placed your fingertip on the paper, the being would see only a circle, the cross-section of your finger touching their world. If you then lifted your finger and placed it elsewhere on the paper, it would seem to the 2-dimensional being that you had disappeared from one location and magically reappeared in another. In a similar way, a 4-dimensional being could move in and out of our 3-dimensional space in ways that would seem impossible. From our perspective, the mystery deepens when we consider how we perceive time. That flowing river that carries us from moment to moment. We experience time as a single direction, always moving forward, never backward. Yet, mathematically, time appears as simply another dimension, different from but related to our 3 spatial dimensions. Time, the silent river. may only be a shadow of a higher flow that our minds cannot yet perceive. Physicists speak of block time, the idea that past, present, and future all exist simultaneously, like different locations in space. From this perspective, the flow of time we experience might be an illusion created by our consciousness as it moves through this four-dimensional block. But what if even this is incomplete? What if time itself has multiple dimensions, branching possibilities that exist simultaneously in some higher dimensional space? The quiet ticking of a clock, measuring seconds and minutes, becomes a contemplative sound when we consider these possibilities. Each tick marks not just the passage of time as we understand it, but perhaps the selection of one possibility from many, the continual creation of our particular reality from an ocean of potential realities. The path not taken in your life doesn't simply cease to exist in some interpretations of quantum mechanics. It continues in another branch of reality, another timeline flowing parallel to our own dot, as your breathing slows and deepens, as the weight of the day gently releases its hold. Consider how these abstract ideas connect to your immediate experience. The mystery of dimensions beyond our perception isn't merely a scientific curiosity. It touches on fundamental questions of existence. What does it mean to be conscious within a potentially infinite, multidimensional cosmos? How might our understanding of purpose and meaning change if we could perceive even briefly the fuller reality that mathematics hints exists? Imagine our universe as a fragile bubble floating within a vast, unseen ocean of other dimensions. This metaphor, though imperfect, helps us visualize how our familiar reality might relate to a larger, more complex whole. Just as a soap bubble reflects light in iridescent patterns while remaining essentially transparent, our universe might reflect aspects of higher dimensions in the patterns and symmetries we observe in nature. The mathematics of our physical laws shows striking symmetries and patterns. The way electrons arrange themselves around atomic nuclei, the precise dance of planets around stars, the spiral structures of galaxies, all follow mathematical rules with an elegance that seems almost intentional. Perhaps this mathematical beauty is a reflection of higher dimensional structures, casting shadows into our simpler three-dimensional experience. Consider the delicate hexagonal structure of a snowflake, forming through nothing more than the molecular properties of water as it crystallizes. No two snowflakes are identical, yet all follow the same underlying pattern, a pattern dictated by forces operating in our three dimensions, but perhaps influenced by higher dimensional structures we cannot perceive. The complexity emerging from simplicity, the order arising from chaos, these might be signatures of higher dimensions touching our reality. The night deepens around us as we consider these possibilities. The darkness is not empty, but filled with potential, with questions that have accompanied humanity since we first gazed at the stars and wondered about our place in the cosmos. Light itself could be a messenger from higher realms, tracing faint outlines of the infinite. Each photon, traveling from distant stars through the vacuum of space, carries information about its source. But what if light carries more than we can currently detect? What if, in its wave-particle duality, light somehow connects to dimensions beyond our current understanding? Einstein's special relativity showed us that as objects approach the speed of light, time slows down for them relative to a stationary observer. At the speed of light itself, time would stop entirely. Photons, the particles of light, experience no passage of time during their journeys across the universe. From their perspective, they are absorbed the instant they are created, even if billions of years pass in our frame of reference. This strange relationship with time hints at connections to realities beyond our everyday experience. As you rest in this moment, aware of your breathing, aware of the space around you, consider how the light touching your skin connects you to the broader universe. Sunlight that warmed your face earlier today began its journey 8 minutes ago in the nuclear furnace of our star. Starlight visible on clear nights may have traveled for hundreds, thousands, or millions of years before reaching your eyes. This ancient light creates a connection across both space and time, a gentle reminder that we exist within a vast cosmic context. The patterns of light and shadow in your room, the subtle colors and textures revealed by this light, all are made possible by photons completing their long journeys from distant sources. Perhaps these photons, moving at the universe's speed limit and experiencing no time in their own frame of reference, somehow touch dimensions beyond our own. Perhaps light itself is a boundary phenomenon, existing at the edge between our familiar dimensions and those that remain hidden from us. Gravity, the gentlest of forces, may be a thread pulling us toward dimensions we can never touch. Of the 4 fundamental forces in nature, electromagnetism, the strong nuclear force, the weak nuclear force, and gravity, is by far the weakest. A small magnet can lift a paperclip, overcoming the gravitational pull of the entire Earth. Yet gravity shapes the largest structures in the universe, gathering stars into galaxies and galaxies into clusters. This disparity between gravity's weakness at small scales and its dominance at large scales has puzzled physicists for decades. One possible explanation lies in extra dimensions. If gravity operates not just in our familiar dimensions, but across higher dimensions as well, its influence would be spread out, appearing weaker in our 3-dimensional space. It would be like trying to hear a conversation through a wall. The sound reaches us, but much of its energy has dispersed in directions we cannot access. When you feel the gentle pressure holding you to Earth, that familiar sensation we take for granted, you might be experiencing the echo of forces operating across dimensions we cannot perceive. The comforting weight of a blanket, the support of the surface beneath you, these mundane experiences connect us to fundamental aspects of reality that extend beyond our immediate understanding. Consider how the moon pulls the oceans, creating the rhythmic dance of tides. This gravitational embrace between celestial bodies, this invisible connection across space, might be just one aspect of a more complex interaction occurring across higher dimensions. The orbits of planets, the spiraling of galaxies, the very structure of the cosmos, all shaped by gravity's gentle hand, perhaps reaching to us from beyond our dimensional boundaries. Perhaps our souls are echoes from a higher dimensional source, projected into this limited frame of space and time. This poetic possibility bridges scientific speculation and spiritual intuition. Throughout human history and across diverse cultures, there has been a persistent sense that consciousness, awareness itself, connects to something beyond the physical brain. From Plato's realm of forms to Eastern concepts of non-dual awareness, humans have long intuited connections between our conscious experience and transcendent realities. Neuroscience shows that our experience of unified consciousness emerges from billions of neurons operating in complex networks. Yet how this physical activity translates into subjective experience, the taste of chocolate, the color blue, the feeling of wonder, remains mysterious. This hard problem of consciousness might hint at connections between our awareness and aspects of reality that extend beyond our three-dimensional physical world. As you rest and listen, notice the spaciousness of your own awareness. Thoughts arise and pass, sensations come and go, yet something remains constant: the awareness that witnesses these changes. This witnessing presence, this consciousness that experiences but is not identical to any experience, might be connected to dimensions beyond our physical reality, not in a supernatural sense, but in the sense that consciousness itself might be a phenomenon that cannot be fully reduced to three-dimensional physical processes. The philosopher Thomas Nagel famously asked what it is like to be a bat, highlighting how conscious experience has an irreducible, subjective quality that seems to resist complete physical explanation. Perhaps this subjective quality, this what it is like aspect of experience, connects to dimensions of reality that transcend the purely physical, not as a dualistic soul separate from the body, but as an emergent phenomenon that bridges dimensional boundaries. Imagine consciousness as a higher dimensional phenomenon that intersects with our three-dimensional brain, like a four-dimensional object casting a three-dimensional shadow. The shadow has properties determined by the higher dimensional object, yet doesn't capture its full reality. Similarly, our neural activities might be the three-dimensional shadow of a consciousness that extends beyond what our current science can measure. The quantum world flickers like a veil. Particles vanish and reappear, hinting at movement across hidden directions. At the smallest scales we can measure, reality behaves in ways that defy our intuitive understanding. Particles exist not in definite locations, but as probability clouds until observed. Pairs of particles can be entangled, influencing each other instantaneously across vast distances. Electrons appear to travel all possible paths simultaneously before resolving into a single measured position. These quantum phenomena suggest a reality more fluid, more interconnected, more mysterious than our everyday experience indicates. When a particle seems to disappear from one location and reappear in another without traversing the space between, a process called quantum tunneling, it might be taking a shortcut through higher dimensions, briefly leaving our three-dimensional space before returning. Consider how this quantum uncertainty might relate to your own experience. Each moment contains infinite possibilities, collapsed into a single reality by the act of observation, by choices made and paths taken. The apparent solidity of your surroundings, of your own body, dissolves under the lens of quantum physics into vibrating fields of probability. This doesn't make reality less real. If anything, it reveals a deeper reality, more rich, more full of potential than we typically perceive. The double-slit experiment, one of the most famous demonstrations of quantum behavior, shows how particles like electrons behave as waves of probability when not observed, creating an interference pattern as if each particle travels through both slits simultaneously. When observed, however, the particles behave like discrete objects going through one slit or the other. This wave-particle duality, this shift between probabilistic waves and definite particles, hints at a reality more complex than our classical understanding allows. Perhaps what we perceive as the strange behavior of quantum particles is simply the shadow of movement in higher dimensions, projected onto our limited three-dimensional perspective. Just as a three-dimensional object passing through a two-dimensional plane would appear to change shape inexplicably from the two-dimensional perspective, quantum particles might be higher-dimensional entities whose movement through our three-dimensional space creates the appearance of probabilistic behavior. Tunneling and entanglement. What we call now might only be a slice of a grander dimensional sculpture where past and future coexist. Einstein's relativity eliminated the concept of universal simultaneity. What counts as now depends on the observer's frame of reference. Two events that appear simultaneous to one observer might appear sequential to another, depending on their relative motion. This suggests that time isn't flowing universally, but is instead relative, observer-dependent. Some physicists have proposed that our experience of flowing time might be like moving a flashlight beam across a fully existing timeline. The past hasn't ceased to exist, nor is the future waiting to be created. All moments exist equally in a four-dimensional block of space-time. Our consciousness creates the illusion of flowing time as it moves through this block, illuminating one moment after another. If this view is correct, then perhaps those we've loved and lost aren't gone, just existing in portions of space-time we can no longer access. Perhaps the uncertainty of the future isn't uncertainty at all. From a higher dimensional perspective, just portions of space-time we haven't yet illuminated with our consciousness. This doesn't eliminate free will or choice. It just suggests that the complete pattern of our choices might exist as a whole, viewable from a higher dimensional perspective. As your mind drifts with these concepts, notice how your breathing continues its gentle rhythm, how the present moment unfolds in your experience. The theoretical possibility of block time doesn't change the vividness of now, the reality of this moment in your conscious experience. Whether time is fundamentally flowing or static, your experience of this moment remains real and meaningful. Perhaps time itself has additional dimensions beyond the linear flow we perceive, just as a line becomes a plane when extended in a second dimension, and a plane becomes a volume when extended in a third. Perhaps our one-dimensional timeline becomes something more complex, more textured when viewed from higher dimensions. The mathematician Hermann Minkowski, whose work helped Einstein develop relativity, described space-time as a four-dimensional manifold where time and space are interwoven. But what if reality contains even more temporal dimensions, creating a structure more complex than we can currently visualize? String theory hums softly in the cosmic dark, suggesting that every vibration is a ripple from unseen realms. This elegant mathematical framework proposes that the fundamental constituents of reality aren't point-like particles, but tiny vibrating strings. Just as different vibrations of a violin string create different musical notes, different vibration patterns of these cosmic strings would create different particles, electrons, quarks, photons, For this mathematics to work, these strings must vibrate in more dimensions than the three spatial dimensions we perceive. Depending on the version of string theory, these extra dimensions might number 6, 7, or even more. Most of these dimensions would be compacted, curled up at scales far too small for our most powerful instruments to detect the harmony of the spheres. An ancient concept suggesting that celestial bodies create an unheard cosmic music as they move finds a curious echo in string theory. The mathematics suggests a universe vibrating with countless frequencies across multiple dimensions, creating the particles and forces that constitute our reality. Perhaps the fundamental nature of reality is more like music than matter, patterns of vibration, creating the appearance of solidity as you breathe quietly, feeling the gentle rise and fall of your chest. Consider how your body consists of atoms vibrating in complex patterns. According to string theory, these atoms themselves consist of particles that are actually vibrating strings, resonating in dimensions we cannot perceive. Your physical existence, seemingly so solid and certain, might be a symphony of multi-dimensional vibrations. A chord played across strings that extend beyond our familiar reality. The mathematics of string theory suggests a universe where everything is connected through these fundamental vibrations. Perhaps what we experience as separate forces, gravity, electromagnetism, the strong and weak nuclear forces, are simply different harmonics of the same underlying strings, vibrating in patterns that create the illusion of separation. Just as a musical instrument can produce many different notes from a single string by changing its tension and vibration pattern, perhaps the universe creates the rich diversity of particles and forces from the vibration of fundamental strings across dimensions we cannot directly observe in the gentle darkness of night. Imagine these cosmic strings humming in perfect mathematical harmony. The elegance of this theory has captivated physicists for decades, not just for its potential to unify our understanding of fundamental forces, but for its sheer beauty. Throughout history, the most enduring scientific theories have often possessed a certain mathematical elegance, simplicity underlying apparent complexity. String theory continues this tradition, suggesting that the bewildering variety of particles catalogued by physicists might arise from variations in a single type of entity vibrating in multiple dimensions. Consider how music affects us emotionally, how certain harmonies can evoke feelings of peace or tension, joy or melancholy. If reality at its most fundamental level resembles music vibrating patterns, creating all we experience, perhaps this explains our deep emotional response to harmony and rhythm. Perhaps when music moves us, we're responding to something that resonates with the very structure of reality, with the multidimensional vibrations that create our world. Could black holes be doorways, tiny folds in space-time connecting dimensions like threads through a cosmic fabric? These mysterious objects, where matter has collapsed to such density that not even light can escape their gravitational pull, represent the most extreme environments we know of in the universe. At the event horizon, the boundary beyond which nothing can escape, space-time curves so dramatically that our mathematics begins to break down. And at the center, where our current physics predicts a singularity of infinite density and zero volume, perhaps something even more extraordinary occurs. Some Theoretical physicists have proposed that black holes might connect to other regions of spacetime through what we call wormholes, theoretical tunnels through the fabric of reality, while Einstein's equations allow for such possibilities. The actual physics of what might exist inside a black hole remains beyond our current understanding. The extreme conditions at the singularity would require a theory that unifies general relativity with quantum mechanics, a theory we don't yet have in complete form. Imagine, though, for a moment, what it might mean if black holes truly were connections to other dimensions or other regions of our universe. The matter and energy falling into these cosmic whirlpools wouldn't be destroyed but transformed, passing through a dimensional doorway into regions beyond our current perception. The billions of black holes scattered throughout our observable universe might be nodes in a vast network connecting regions of space-time that appear completely separate from our limited perspective. As you lie still, feeling the gentle weight of your body against the surface supporting you, consider how gravity itself, that most familiar force that holds you to Earth, remains, in many ways, the most mysterious of the fundamental forces. Black holes represent gravity in its most extreme form, where the curvature of spacetime becomes infinite according to our current models. Perhaps it is precisely at these points of infinite curvature that connections to higher dimensions become possible, where the fabric of reality folds back upon itself to create bridges between seemingly separate regions. The poet William Blake wrote of seeing the world in a grain of sand and heaven in a wildflower. Perhaps in the darkness of a black hole, in the seemingly destructive vortex of gravity gone extreme, there exists not an ending, but a beginning, a connection to realms beyond our current understanding. The apparent destruction might be merely transformation, a passage from one state of being to another through dimensional doorways we're only beginning to theorize about when we dream. Maybe our consciousness slips briefly between layers of the dimensional tapestry. Throughout human history, the dream state has fascinated philosophers, scientists, and spiritual seekers alike. In that borderland between waking and sleeping, we experience realities that feel as vivid as our waking world, yet operate according to different rules. Time and space become fluid, identities shift and merge, and possibilities, normally constrained by physical laws, become available to our experience. Ancient cultures often viewed dreams as journeys of the soul to other realms, as communications from deities or ancestors, or as glimpses into possible futures. While modern neuroscience explains many aspects of dreaming as the brain's processing of memories, emotions, and experiences, the subjective experience of dreaming maintains a quality that feels like accessing another mode of being. Notice, if you've ever had a lucid dream, a dream where you became aware you were dreaming while still within the dream state, how that awareness created a curious intersection between waking consciousness and dream reality. In that state, you existed simultaneously in two modes of experience. Aware of your physical body, resting in bed, even as you navigated the dream landscape. This dual awareness might offer a faint echo of what it might be like to perceive higher dimensions, while still anchored in our familiar three-dimensional reality. The fluid nature of dream spaceware locations can merge and transform. where you can move from one setting to another without traversing the space between, bears curious similarities to how we might imagine movement through higher dimensions. Just as a being capable of moving through the fourth dimension could appear to teleport from our three-dimensional perspective. In dreams, we often experience transitions that bypass normal spatial relationships. As your consciousness drifts toward sleep, becoming less tightly bound to sensory input, perhaps it naturally expands into a less constrained relationship with dimensional reality. Not literally accessing higher dimensions, perhaps, but experiencing a different mode of consciousness that hints at realities beyond our waking perception, a mode less bound by the limitations of three-dimensional thinking and linear time. The half-dreaming state we sometimes experience as we fall asleep or awaken, when thoughts become unusually fluid and creative connections form more readily, has been cultivated by artists and scientists throughout history as a source of inspiration. Salvador Dali would doze off, holding a spoon over a metal plate, knowing that when he fell asleep, the spoon would clatter down and wake him, allowing him to capture the imagery from the threshold between waking and dreaming. Perhaps this liminal state allows a different kind of perception, one that intuitively grasps connections and possibilities that our fully wakeful mind, focused on navigating three-dimensional reality, might miss. The chemist Auguste Kekule famously discovered the ring structure of benzene after dreaming of a snake biting its own tail. The mathematician Srinivasa Ramanujan attributed many of his remarkable insights to dreams where the goddess Namagiri would show him mathematical formulas. Einstein's special relativity was preceded by a dream where he was sledding down a mountainside, approaching the speed of light. These creative breakthroughs suggest that the dream state might offer a different perspective on reality, one less constrained by conventional thinking and perhaps more open to intuitive connections with deeper aspects of reality. As you drift between wakefulness and sleep, notice how your thoughts begin to flow more freely, how images and ideas combine in new and unexpected ways. This natural loosening of cognitive boundaries might allow glimpses of connections and patterns normally hidden by our waking focus on navigating the physical world. The dream state doesn't literally transport us to other dimensions, perhaps, but it might offer a different mode of perception that hints at the multidimensional nature of reality. The stars above may be projections on the ceiling of a theater, shimmering illusions of deeper truths. This poetic metaphor invites us to consider how our perception of the cosmos might relate to a more complex reality. When we look at the night sky, we see points of light against darkness. But these points are immense suns, many larger than our own, appearing tiny only because of their immense distance. What if the vastness of space itself, the three-dimensional cosmos we observe with our telescopes, is similarly a projection or partial view of something more fundamental? The holographic principle, a concept from theoretical physics, suggests something along these lines, that all the information contained in a volume of space can be represented as information on the boundary of that region. Just as a two-dimensional hologram can create the illusion of three dimensions, our three-dimensional reality might be encoded on a two-dimensional boundary of some larger structure. If you've ever watched shadows play across a wall as objects move in front of a light source, you've seen how three-dimensional reality can cast two-dimensional projections The shadows capture some information about the objects casting them, but lose other information. In a similar way, our three-dimensional universe might be a kind of shadow or projection of higher dimensional processes, capturing some aspects of that reality while losing others. This perspective doesn't diminish the beauty or reality of our cosmic experience. A shadow still reveals the shape of the object casting it, even if it loses information about color and texture. Similarly, our three-dimensional cosmos might still reveal genuine aspects of a higher dimensional reality, even if our perspective captures only a portion of the complete picture. Consider the night sky again, the countless stars scattered across the darkness. Each star represents not just a point of light, but a history of nuclear fusion, of gravitational collapse, of elements forming and energy radiating across vast distances. What if these processes that we understand in three-dimensional terms are themselves projections of more complex, higher-dimensional phenomena? What if the mathematics that describes stellar evolution hints at connections to dimensions beyond our direct perception? Space itself might be curved not only in three dimensions but folded into unseen geometries that cradle reality. Einstein showed us that space is not flat but curved by the presence of mass and energy. This curvature is what we experience as gravity. But what if space has additional curvatures in dimensions we cannot directly perceive? Mathematicians describe various kinds of spaces with extra dimensions and exotic geometries. Calabi-Yau manifolds, for instance, are six-dimensional geometric structures that might describe the compacted extra dimensions in string theory. While impossible to visualize completely, these complex geometrical spaces could underlie the structure of reality at the smallest scales. Consider how a piece of paper can be flat in two dimensions, yet curved in the third dimension when folded into an origami shape. Our three-dimensional space might similarly be folded in higher dimensions, creating connections and structures invisible to our direct perception but influencing the behavior of particles and forces in our universe. The mathematician Georg Bernhard Riemann, whose work later provided the mathematical foundation for Einstein's general relativity, developed ways of describing curved spaces with any number of dimensions. These Riemannian geometries allow us to mathematically model spaces that curve and fold in ways that transcend our visual imagination. Perhaps the true shape of our cosmos includes such higher dimensional folding, creating a structure far more intricate and interconnected than our three-dimensional perspective reveals. If you've ever tried to flatten a globe onto a flat map, you've encountered the impossibility of representing a curved surface in fewer dimensions without distortion. Every map of Earth distorts either shape, size, or distance. It's mathematically impossible to avoid all three types of distortion. Similarly, our three-dimensional perception of reality might necessarily involve distortions or simplifications of a higher dimensional truth map that captures some aspects of reality while inevitably distorting others. These mathematical descriptions of curved and folded spaces aren't merely abstract exercises. They provide potential explanations for observed phenomena in our universe. The large-scale structure of the cosmos, the behavior of fundamental particles, the nature of gravity itself. Fall might be influenced by the geometry of dimensions beyond our direct perception. The fifth dimension could hold infinite versions of us all thinking, breathing, existing in overlapping symphonies. This concept touches on the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of every quantum event occurs in some branch of reality, rather than probability waves collapsing into a single reality when observed. This interpretation proposes that reality branches, with each possible outcome occurring in a different branch or world. If true, there would be versions of you who made different choices at key moments, versions where historical events unfolded differently, versions where the laws of physics themselves might vary slightly. These parallel realities wouldn't exist in our three-dimensional space, but might be arranged across additional dimensions, forming a vast multiverse of possibilities. This idea speaks to ancient human questions about fate, choice, and possibility. The roads not taken in your life, the choices unmade, the words unspoken in a multi-dimensional multiverse. These possibilities might all exist, branching out across dimensions we cannot perceive, but that mathematics suggests might be real. Quantum physics reveals that at the smallest scales, reality exists as fields of probability until observed or measured. The famous double-slit experiment shows that particles like electrons or photons can behave as waves of probability, seeming to take all possible paths simultaneously until observed. This wave-like behavior creates an interference pattern that can only be explained if the particle somehow travels through both slits at once, as if existing in multiple places simultaneously. The many worlds interpretation suggests that rather than these probabilities collapsing into a single outcome, reality itself branches, with each possible outcome occurring in a different branch or world. From this perspective, the probability wave doesn't collapse rather. Our consciousness follows one particular branch, becoming unable to perceive the others. As you rest in this moment, aware of your breathing, aware of the weight of your body, consider how this particular configuration of atoms, this particular collection of memories and experiences that you call you, might be one expression of a higher dimensional pattern, not in a way that diminishes your uniqueness or importance, but in a way that connects your particular existence to a broader, richer reality. The physicist Hugh Everett, who first proposed the many worlds interpretation, suggested that all possible outcomes of quantum measurements occur in some world or universe. In this view, the universe continually splits into multiple copies, one for each possible outcome of each interaction. These worlds don't interact after they split, which is why we experience only one reality. Yet mathematically, the others would continue to exist, perhaps arranged across dimensions beyond our perception. This interpretation has profound implications for our understanding of choice and possibility. Every decision point in your life might represent a branching of realities across higher dimensions. The person you are now is the result of countless such branchings, and in some sense, all other possibilities might exist as well versions of you who made different choices, experienced different outcomes, developed along different trajectories. Rather than finding this perspective unsettling, there can be a curious comfort in it. The weight of what if and if only might ease when we consider that, in some sense, all possibilities play out across the dimensional tapestry of reality. Nothing is truly lost, only separated from our particular branch of experience by dimensional barriers we cannot currently cross. This gentle understanding doesn't diminish the importance of our choices or the reality of our particular path. Instead, it offers a cosmic perspective that softens the sharp edges of regret and uncertainty. Consider those moments of hesitation in your life, those crossroads where you paused, weighing options, feeling the weight of decision. Perhaps you've wondered about the roads not taken, the career opportunities declined, the relationships that might have flowered had you spoken different words, the places you might have called home had you moved when the thought first arose. In our conventional understanding, these untaken paths simply vanish, becoming nothing more than fading memories and occasional wonderings. But the mathematics of quantum reality suggests a more expansive possibility. Each choice point might represent not an elimination of possibilities, but a branching of realities across dimensions we cannot directly perceive. The version of you who took that different job, who expressed those unspoken feelings, who moved to that distant city, perhaps these versions continue their journey in parallel branches of reality, exploring possibilities your consciousness cannot access but that mathematics suggests might exist. The physicist David Deutsch, in his work on quantum computation, argues that certain quantum algorithms solve problems by performing calculations in parallel universes. When a quantum computer manipulates qubits existing in superpositions of states, it effectively processes information across multiple realities simultaneously. The results of these calculations, accessible in our reality, seem to require computational resources beyond what exists in our observable universe. Perhaps the boundaries between dimensions are more permeable than we imagine, with information occasionally flowing between seemingly separate realms of possibility. As you rest now, breathing softly in the quiet darkness, imagine your consciousness as a thread woven into this vast tapestry of possibility. The specific pattern of your experiences, memories, choices, and circumstances represents one unique pathway through the infinite dimensional landscape. Yet this thread connects to countless others variations of yourself exploring different possibilities, experiencing different outcomes, developing along different trajectories. Rather than isolation, this perspective offers a profound kind of connection, a sense that nothing is truly lost to possibility. This understanding might transform how we hold life's uncertainties. The anxiety that often accompanies major decisions, the fear of choosing wrongly, of missing opportunities, of taking irreversible wrong turns might soften when we consider that perhaps all possibilities unfold somewhere in the dimensional spectrum. This doesn't absolve us of responsibility for thoughtful choice in our particular reality, but it offers a spaciousness around the process, a cosmic perspective that can soothe the anxiety of uncertainty. The comfort extends to our connections with others as well. Those relationships that circumstances pulled apart, those loved ones now distant or departed, perhaps in other branches of reality, those connections continue to flourish. The conversations left unfinished, the words of appreciation unspoken, the reconciliations that never occurred in our timeline, perhaps somewhere across the dimensional boundaries. These possibilities play out in fullness. Nothing is truly lost, only unfolding beyond our current perception. Entropy, the measure of cosmic decay, may simply be the shadow of higher-order harmony beyond our perception. In our familiar experience, order tends toward disorder. A cup falls and breaks, but broken pieces never spontaneously reassemble into a cup. Heat flows from hot objects to cold ones, never the reverse. Ice cubes melt in warm water, but warm water never spontaneously forms ice cubes while becoming warmer itself. This tendency toward increasing disorder is measured as entropy, and it gives time its apparent direction. The arrow of time points toward increasing entropy, the second law of thermodynamics, which describes this inevitable increase of entropy, shapes our everyday experience in profound ways. The foods we eat gradually break down, providing energy for our bodies. The fuels we burn disperse their energy as heat that dissipates into the environment. The stars themselves gradually exhaust their nuclear fuel, dispersing their energy into space. Even information degrades over time without constant maintenance and renewal. This relentless flow from order to disorder, from usable energy to unusable, from complexity to simplicity, seems built into the fabric of reality. Yet this apparently universal tendency toward disorder presents a puzzle that has intrigued physicists for generations. If entropy always increases, why do we observe so much order in the universe? How did complex structures like galaxies, solar systems, living organisms, and conscious minds emerge from the hot, uniform plasma that existed shortly after the Big Bang? The early universe, with its nearly uniform distribution of energy, was in a state of relatively high entropy. The universe we observe today, with its complex structures at all scales, from atoms to superclusters of galaxies, exhibits remarkable order. This apparent contradiction invites deeper contemplation. One answer lies in the role of gravity, which, unlike other forces, tends to organize matter into ever more complex structures across cosmic timescales. While most physical processes increase entropy by dispersing energy and matter, gravitational attraction does the opposite. It gathers matter together, creating stars, planets, and galaxies from diffuse clouds of gas and dust. The gravitational clumping of matter allows for local decreases in entropy, creating the conditions necessary for more complex structures to emerge. Another possible answer might lie in the limitations of our dimensional perspective. Perhaps what appears as increasing disorder from our limited three-dimensional viewpoint is actually part of a more complex process when viewed from higher dimensions. What looks like irreversible decay in our experience might be one phase of a larger cycle or pattern that our perspective cannot fully comprehend. Consider a hurricane as an analogy. From within the storm, you would experience chaotic, destructive winds, the epitome of disorder and entropy. But viewed from above, the hurricane reveals itself as a beautifully organized spiral structure, with energy flowing through the system in precisely coordinated patterns. The apparent chaos at ground level is actually part of a larger order visible only from a higher perspective. Similarly, what we perceive as increasing entropy might be part of a higher dimensional pattern that our three-dimensional perspective cannot fully comprehend. Just as a two-dimensional being could not understand the organization of a three-dimensional object passing through its plane, perhaps the entropy we observe represents the three-dimensional shadow, of more complex processes extending into dimensions beyond our direct perception. The physicist Roger Penrose has proposed a cosmological model called conformal cyclic cosmology that suggests our universe goes through endless cycles of expansion. Each cycle begins with a big bang and ends with an increasingly dilute state as matter breaks down and black holes eventually evaporate through Hawking radiation. The end state of one cycle, with its seemingly maximum entropy, would actually match the conditions of the beginning of the next cycle. In this model, what appears as irreversible decay from our temporal perspective might be part of an eternal cosmic renewal. When viewed from outside our particular timic, as you breathe quietly, feeling the gentle rhythm of your body, consider how this rhythm itself represents a local decrease in entropy, temporary, organized pattern maintained by the flow of energy through your open system. Each breath draws oxygen molecules into your lungs, where they diffuse into your bloodstream and travel to cells throughout your body. These cells use the oxygen in precisely coordinated chemical reactions, releasing energy that powers everything from your heartbeat to your thoughts. This intricate biological machinery, this temporary victory over entropy's flow, connects you to the cosmic puzzle of order emerging from apparent disorder. The physicist Hugh Everett, who first proposed the many worlds interpretation, suggested that all possible outcomes of quantum measurements occur in some world or universe. In this view, the universe continually splits into multiple copies, one for each possible outcome of each interaction. These worlds don't interact after they split, which is why we experience only one reality. Yet mathematically, the others would continue to exist, perhaps arranged across dimensions beyond our perception. This interpretation has profound implications for our understanding of choice and possibility. Every decision point in your life might represent a branching of realities across higher dimensions. The person you are now is the result of countless such branchings, and in some sense, all other possibilities might exist as well versions of you who made different choices, experienced different outcomes, developed along different trajectories. Rather than finding this perspective unsettling, there can be a curious comfort in it. The weight of what if and if only might ease when we consider that, in some sense, all possibilities play out across the dimensional tapestry of reality. Nothing is truly lost, only separated from our particular branch of experience by dimensional barriers we cannot currently cross. This gentle understanding doesn't diminish the importance of our choices or the reality of our particular path. Instead, it offers a cosmic perspective that softens the sharp edges of regret and uncertainty. Consider those moments of hesitation in your life, those crossroads where you paused, weighing options, feeling the weight of decision. Perhaps you've wondered about the roads not taken, the career opportunities declined, the relationships that might have flowered had you spoken different words, the places you might have called home had you moved when the thought first arose. In our conventional understanding, these untaken paths simply vanish, becoming nothing more than fading memories and occasional wonderings. But the mathematics of quantum reality suggests a more expansive possibility. Each choice point might represent not an elimination of possibilities, but a branching of realities across dimensions we cannot directly perceive. The version of you who took that different job, Who expressed those unspoken feelings? Who moved to that distant city? Perhaps these versions continue their journey in parallel branches of reality, exploring possibilities your consciousness cannot access, but that mathematics suggests might exist. The physicist David Deutsch, in his work on quantum computation, argues that certain quantum algorithms solve problems by performing calculations in parallel universes. When a quantum computer manipulates qubits existing in superpositions of states, it effectively processes information across multiple realities simultaneously. The results of these calculations, accessible in our reality, seem to require computational resources beyond what exists in our observable universe. Perhaps the boundaries between dimensions are more permeable than we imagine, with information occasionally flowing between seemingly separate realms of possibility. As you rest now, breathing softly in the quiet darkness, imagine your consciousness as a thread woven into this vast tapestry of possibility. The specific pattern of your experiences, memories, choices, and circumstances represents one unique pathway through the infinite dimensional landscape. Yet this thread connects to countless others variations of yourself exploring different possibilities, experiencing different outcomes, developing along different trajectories. Rather than isolation, this perspective offers a profound kind of connection, a sense that nothing is truly lost to possibility. This understanding might transform how we hold life's uncertainties. The anxiety that often accompanies major decisions, the fear of choosing wrongly, of missing opportunities, of taking irreversible wrong turns might soften when we consider that perhaps all possibilities unfold somewhere in the dimensional spectrum. This doesn't absolve us of responsibility for thoughtful choice in our particular reality, but it offers a spaciousness around the process, a cosmic perspective that can soothe the anxiety of uncertainty. The comfort extends to our connections with others as well. Those relationships that circumstances pulled apart, those loved ones now distant or departed, perhaps in other branches of reality, those connections continue to flourish. The conversations left unfinished, the words of appreciation unspoken, the reconciliations that never occurred in our timeline, perhaps somewhere across the dimensional boundaries. These possibilities play out in fullness. Nothing is truly lost, only unfolding beyond our current perception. Entropy, the measure of cosmic decay, may simply be the shadow of higher-order harmony beyond our perception. In our familiar experience, order tends toward disorder. A cup falls and breaks, but broken pieces never spontaneously reassemble into a cup. Heat flows from hot objects to cold ones, never the reverse. Ice cubes melt in warm water, but warm water never spontaneously forms ice cubes while becoming warmer itself. This tendency toward increasing disorder is measured as entropy, and it gives time its apparent direction. The arrow of time points toward increasing entropy, the second law of thermodynamics, which describes this inevitable increase of entropy, shapes our everyday experience in profound ways. The foods we eat gradually break down, providing energy for our bodies. The fuels we burn disperse their energy as heat that dissipates into the environment. The stars themselves gradually exhaust their nuclear fuel, dispersing their energy into space. Even information degrades over time without constant maintenance and renewal. This relentless flow from order to disorder, from usable energy to unusable, from complexity to simplicity, seems built into the fabric of reality. Yet this apparently universal tendency toward disorder presents a puzzle that has intrigued physicists for generations. If entropy always increases, why do we observe so much order in the universe? How did complex structures like galaxies, solar systems, living organisms, and conscious minds emerge from the hot, uniform plasma that existed shortly after the Big Bang? The early universe, with its nearly uniform distribution of energy, was in a state of relatively high entropy. The universe we observe today, with its complex structures at all scales, from atoms to superclusters of galaxies, exhibits remarkable order. This apparent contradiction invites deeper contemplation. One answer lies in the role of gravity, which, unlike other forces, tends to organize matter into ever more complex structures across cosmic timescales. While most physical processes increase entropy by dispersing energy and matter, gravitational attraction does the opposite. It gathers matter together, creating stars, planets, and galaxies from diffuse clouds of gas and dust. The gravitational clumping of matter allows for local decreases in entropy, creating the conditions necessary for more complex structures to emerge. Another possible answer might lie in the limitations of our dimensional perspective. Perhaps what appears as increasing disorder from our limited three-dimensional viewpoint is actually part of a more complex process when viewed from higher dimensions. What looks like irreversible decay in our experience might be one phase of a larger cycle or pattern that our perspective cannot fully comprehend. Consider a hurricane as an analogy. From within the storm, you would experience chaotic, destructive winds, the epitome of disorder and entropy. But viewed from above, the hurricane reveals itself as a beautifully organized spiral structure, with energy flowing through the system in precisely coordinated patterns. The apparent chaos at ground level is actually part of a larger order visible only from a higher perspective. Similarly, what we perceive as increasing entropy might be part of a higher dimensional pattern that our three-dimensional perspective cannot fully comprehend. Just as a two-dimensional being could not understand the organization of a three-dimensional object passing through its plane, perhaps the entropy we observe represents the three-dimensional shadow of more complex processes extending into dimensions beyond our direct perception. The physicist Roger Penrose has proposed a cosmological model called conformal cyclic cosmology that suggests our universe goes through endless cycles of expansion. Each cycle begins with a Big Bang and ends with an increasingly dilute state as matter breaks down and black holes eventually evaporate through Hawking radiation. The end state of one cycle, with its seemingly maximum entropy, would actually match the conditions of the beginning of the next cycle. In this model, what appears as irreversible decay from our temporal perspective might be part of an eternal cosmic renewal. When viewed from outside our particular timic, as you breathe quietly, feeling the gentle rhythm of your body, consider how this rhythm itself represents a local decrease in entropy, a temporary, organized pattern maintained by the flow of energy through your open system. Each breath draws oxygen molecules into your lungs, where they diffuse into your bloodstream and travel to cells throughout your body. These cells use the oxygen in precisely coordinated chemical reactions, releasing energy that powers everything from your heartbeat to your thoughts. This intricate biological machinery, this temporary victory over entropy's flow, connects you to the cosmic puzzle of order emerging from apparent disorder. Your existence as a conscious being capable of creating order through thought and action seems to run counter to entropy's general tendency. You organize information into meaningful patterns, create and maintain structures in your environment, cultivate relationships that increase rather than decrease complexity and order. Perhaps this capacity reflects connections to organizing, principles that transcend our three-dimensional perspective. The Nobel Prize-winning chemist Ilya Prigogine specialized in studying systems far from equilibrium conditions, where order spontaneously emerges from disorder. He won the Nobel Prize for his work on dissipative structure systems that maintain local order by processing energy flows in specific ways, creating islands of order within entropy's general flow. Living organisms represent the most sophisticated examples of such structures, maintaining their complex organization by constantly processing energy and matter. When you observe a forest ecosystem, you witness a remarkable example of order emerging and maintaining itself through energy flow. Plants capture sunlight through photosynthesis, creating complex organic molecules from simple carbon dioxide and water. Animals consume these plants, breaking down these molecules to power their own complex biological processes. Decomposers return minerals to the soil, completing cycles that can maintain themselves for thousands or millions of years. The forest as a whole represents a dissipative structure maintaining its order by processing the constant flow of solar energy, exporting entropy to its surroundings while preserving and even increasing its internal complexity. Perhaps our entire universe operates as a dissipative structure on a cosmic scale, maintaining its complex structures by exporting entropy across dimensional boundaries we cannot directly perceive. Just as a living organism maintains its order by exchanging matter and energy with its environment, perhaps our universe maintains its remarkable structures through exchanges with higher dimensions or parallel realities that lie beyond our direct observation. Prigogine's work revealed that at certain critical thresholds, chaotic systems can spontaneously reorganize into higher levels of order. Small fluctuations can amplify through feedback loops, causing dramatic reorganization of entire systems. These bifurcation points represent moments where multiple possible futures branch from a single unstable present. Perhaps these mathematical descriptions of emergence and self-organization offer glimpses of how higher dimensional influences might manifest in our observable reality. As night deepens around us, imagine the vast cosmic scales where entropy plays out. Visualize the graceful rotation of our galaxy, billions of stars moving in coordinated harmony around the galactic center. As galaxies spin, their motion could be the visible signature of a multidimensional dance. The spiraling arms of galaxies, rotating around central core where supermassive black holes often reside, create some of the most beautiful structures in our universe. The mathematics that describes these rotating systems reveals complex interactions between visible matter, dark matter, and the curvature of space-time itself. The Milky Way completes one rotation, approximately every 230 million years, a time span so vast that when our solar system last occupied this same position in the galaxy, dinosaurs had not yet appeared on Earth. Yet this majestic cosmic dance follows mathematical patterns of remarkable precision. The spiral arms, the distribution of star clusters, the orbital velocities of stars at different distances from the galactic center all follow patterns that astronomers can measure and mathematicians can model. Yet these models remain incomplete in curious ways. When scientists calculate the gravitational effects of the visible matter in galaxies, the numbers don't match observations. Galaxies rotate faster than they should, based on their observable mass. The outer regions of spiral galaxies move at nearly the same speed as regions closer to the center, contrary to what we would expect from the visible distribution of matter. This discrepancy led to the concept of dark matter invisible mass that we can detect only through its gravitational effects. Physicists have suggested that the rotation of galaxies might be influenced by extra-dimensional effects. The distribution of dark matter, which seems to form a spherical halo around galaxies, might be explained by connections to higher dimensions. Perhaps what we observe as dark matter represents mass existing primarily in higher dimensions, affecting our three-dimensional space through gravity's unique ability to operate across dimensional boundaries. If you look at photographs of different spiral galaxies, you might notice striking similarities in their structures despite their different sizes and histories. The spiral arms often follow patterns related to the golden ratio, the same mathematical relationship found in the spiral arrangement of seeds in a sunflower head, the branching patterns of trees, even the proportions of the human body. These mathematical echoes across vastly different scales hint at underlying principles that transcend specific physical systems, perhaps connecting to geometric properties of higher dimensions that manifests in our 3D reality as recurring patterns. Perhaps what we see as the majestic rotation of billions of stars around galactic centers is a cross-section of a more complex pattern extending into dimensions we cannot directly observe. The galaxy's spiral arms, traced by the light of billions of stars, might be the visible signature of processes unfolding across multiple dimensions of reality. What appears to us as galactic rotation might be the three-dimensional shadow of a more complex movement occurring in higher dimensional space. The mathematics describing these galactic structures contains symmetries and patterns that hint at deeper organizational principles. The physicist Antimatter discovered the profound connection between symmetries and conservation laws, showing that symmetries in physical systems correspond to quantities that remain unchanged through transformations. Time symmetry connects to conservation of energy. Rotational symmetry connects to conservation of angular momentum. These mathematical relationships reveal the deep structure underlying physical reality. Perhaps the symmetries we observe in 3 dimensions, from the spiral arms of galaxies to the hexagonal patterns of snowflakes, represent projections of more complex symmetries existing in higher dimensions. Just as a cube casting a shadow on a wall might create a hexagonal shadow when oriented correctly, perhaps the mathematical patterns we observe in nature are shadows of higher dimensional structures, projecting into our three-dimensional reality between the vast galactic scales and the subatomic realm lies the apparent emptiness of space, the vacuum that seems to separate objects from each other. Yet modern physics reveals that this emptiness is an illusion. Even the silence between atoms might be filled with the pulse of higher dimensional energy. The vacuum of space, once thought to be simply nothing, teems with activity at the quantum level. Virtual particles continuously appear and disappear in complementary pairs. Quantum fields fluctuate in complex patterns, and zero-point energy pervades even the emptiest regions of space. The physicist Richard Feynman famously noted that empty space is not empty, according to quantum field theory. Particles themselves are excitations of underlying fields that extend throughout the universe. Electrons, photons, quarks all represent particular vibrations or excitations in quantum fields that permeate all of space. These fields exist everywhere, their potential for manifestation present even in apparently empty vacuum. The Casimir effect, first predicted by the Dutch physicist Hendrik Casimir in 1948 and later confirmed experimentally, demonstrates the reality of these quantum fluctuations in vacuum. When two uncharged metal plates are placed extremely close together in a vacuum, they experience a small but measurable attractive force. This occurs because the restricted space between the plates limits the wavelengths of virtual particles that can form there compared to the unlimited wavelengths possible outside the plates. This imbalance creates a pressure difference that pushes the plates together, a force arising from the quantum nature of supposedly empty space. Theories suggest that this vacuum energy might be related to influences from compacted extra dimensions or parallel brains, membrane-like structures in certain versions of string theory. The Bragg scenario in some versions of string theory suggests that our three-dimensional universe exists on a membrane or brain embedded in a higher dimensional space. Other brains might exist parallel to ours, separated by distances in dimensions we cannot directly perceive. The vacuum energy we observe might be influenced by these extra-dimensional structures, with quantum fluctuations potentially representing connections across dimensional boundaries. When you sit in silence, aware of the apparent emptiness around you, consider that this emptiness might be an illusion created by the limitations of our senses. The space between atoms, between you and everything around you, pulses with quantum activity, with fields and forces that connect all things in ways invisible to direct perception but increasingly accessible to scientific understanding. If you could somehow perceive the space between atoms, between the molecules that make up your body and everything around you, you wouldn't find emptiness but rather an ocean of quantum fields extending throughout the universe. These fields represent the potential for particles to exist, electrons, photons, quarks, all manifestations of underlying fields that permeate all of space. Perhaps these quantum fields themselves connect to higher dimensions, their fluctuations influenced by or resonating with realities beyond our direct perception. Physicist David Bohm proposed that underlying the quantum realm we observe lies what he called the implicate order, a deeper level of reality in which everything is interconnected in ways that transcend ordinary space and time. In Bohm's view, the separate objects and events we perceive represent and explicate order that unfolds from this more fundamental implicate reality. Similar to how distinct images appear when a hologram is illuminated from different angles, Bohm's perspective suggests that the quantum fluctuations in vacuum energy might represent ripples or movements in this deeper implicate order reality, more fundamental than the three-dimensional space and linear time we typically experience. Perhaps what we perceive as emptiness actually contains, in enfolded form, the entirety of existence, perspective that resonates with ancient philosophical concepts from various wisdom traditions. As you breathe quietly, feeling the gentle rhythm of your body, consider how even the apparent emptiness of the space around you connects you to the broader cosmos. The quantum fields that permeate the space within and around your body extend throughout the universe, connecting you to distant stars and galaxies through their continuous presence. Perhaps these quantum fields themselves connect to higher dimensions, their fluctuations influenced by or resonating with realities beyond our direct perception. This understanding of the cosmos, where even apparent emptiness contains the seeds of all possibilities, brings us back to consciousness itself, the awareness through which we experience these mysteries. To understand these realms of higher dimensions, we must not only look outward to the stars and inward to the quantum world, but also examine the nature of the awareness that perceives these phenomena throughout human history. Contemplative traditions have suggested that consciousness itself might hold keys to understanding deeper aspects of reality. From the Vedantic concept of Atman, the self that is one with Brahman, the ultimate reality, to Buddhist explorations of the nature of mind. From Plato's allegory of the cave to phenomenological investigations of conscious experience, humans have long intuited connections between inner awareness and cosmic truth. Edmund Husserl developed a method called phenomenological reduction to investigate consciousness directly by temporarily suspending assumptions about the external causes of experience and focusing on the structure of experience itself. Husserl suggested we might gain insights into the nature of consciousness that cannot be accessed through objective, third-person investigation alone. This first-person approach to understanding consciousness complements the third-person approach of neuroscience and physics, potentially offering insights that objective measurement alone cannot provide. The physicist and philosopher Wolfgang Pauli, working with psychologist Carl Jung, explored the curious connections between the mind's archetypal patterns and the mathematical structures of physical reality. They noted striking parallels between the symbols that spontaneously arise in dreams and mythology and the mathematical patterns discovered in physics. These connections suggested to them a psychophysical reality, transcending the conventional division between mind and matter. Modern theories in physics sometimes echo these ancient insights. The measurement problem in quantum mechanics highlights the strange role of observation in determining physical reality. In the standard Copenhagen interpretation, a particle exists as a probability wave until observed or measured, at which point the wave function collapses into a specific state. This suggests a peculiar relationship between consciousness and physical reality, though most physicists are careful not to claim that human consciousness specifically causes this collapse. Physicist John Wheeler proposed the concept of a participatory universe, suggesting that the act of observation is not passive but participatory in creating the reality we experience. In his words, no phenomenon is a real phenomenon until it is an observed phenomenon. Wheeler didn't claim that reality doesn't exist without human observation, but rather that the specific forms reality takes emerge through interaction between observer and observed. His famous delayed choice experiments suggest that observation in the present can influence how we must describe events in the past, challenging our conventional understanding of causality. Wheeler represented this participatory aspect of reality with a U diagram, showing the universe as a self-excited circuit. In this view, the universe evolves to a point where observers emerge, and these observers then participate in creating the reality they observe, including the past conditions that led to their emergence. This paradoxical loop suggests a reality far more pseudo, interconnected, and self-referential than our conventional understanding allows. As you rest in quiet awareness, notice how your consciousness illuminates your experience. Sights, sounds, sensations, thoughts all appear within the space of awareness. This awareness itself, this capacity for experience, remains one of the deepest mysteries we face. How does consciousness arise? What is its relationship to the physical world? These questions may ultimately connect to our understanding of dimensions beyond our familiar three. The philosopher Thomas Nagel pointed out the difficulty of reducing consciousness to purely physical processes. In his famous paper, What Is It Like to Be a Bat?, he argued that the subjective experience of consciousness, the what it is like aspects, seems to resist complete explanation in objective, physical terms. This explanatory gap between physical processes and subjective experience has led some philosophers and scientists to consider whether consciousness might involve properties or dimensions beyond our current scientific understanding. The philosopher David Chalmers distinguishes between the easy problems and the hard problem of consciousness. The easy problems, which are not actually easy but are approachable through conventional scientific methods, involve explaining specific mental functions like memory, attention, and behavioral control. The hard problem involves explaining why these physical processes are accompanied by subjective experience at all. Why should certain arrangements of matter be associated with an inner life, with feelings, sensations, and thoughts? This question points toward mysteries at the heart of our understanding of reality as night deepens into its quietest hours. Notice the spacious quality of your own awareness. Thoughts arise and pass, sensations come and go, yet something remains, constant: the awareness that witnesses these changes. This witnessing presence, this consciousness that experiences but is not identical to any experience, might be connected to dimensions beyond our physical reality, not in a supernatural sense, but in the sense that consciousness itself might be a phenomenon that cannot be fully reduced to three-dimensional physical processes. Perhaps our journey through higher dimensions ultimately leads us back to ourselves, to the awareness that witnesses the cosmos and somehow contains it within subjective experience, not in a solipsistic sense that denies external reality, but in a recognition that consciousness and cosmos are intertwined in ways we don't yet fully understand. The ancient Greek philosophers distinguished between episteme, scientific knowledge, and gnosis, direct knowing. Modern science has excelled at developing episteme, detailed models and theories that predict and explain natural phenomena. But perhaps understanding the true nature of reality also requires gnosis, direct experiential knowing that comes not just from observing external reality, but from exploring the nature of awareness itself. Throughout history, contemplative traditions have developed sophisticated methods for this. Inner exploration meditation practices that quiet the discursive mind and allow awareness to rest in its own nature. These traditions suggest that when consciousness turns back upon itself, when awareness becomes aware of awareness, certain insights about the nature of reality become directly accessible, not as theoretical knowledge, but as lived experience. The Tibetan Buddhist tradition describes Rigpa, natural, primordial awareness that recognizes its own nature when conceptual thinking subsides. The Vedantic tradition speaks of the self-luminous nature of consciousness, its capacity to know itself by its own light. Zen Buddhism points to the original face before your parents were born, the awareness that precedes and transcends personal identity. These traditions suggest that our ordinary consciousness, with its sense of being a separate self, navigating a world of separate objects, represents a limited mode of perception that can open to more fundamental levels of awareness. Modern cognitive science is beginning to explore these contemplative insights through rigorous research. Studies of long-term meditators reveal how attention, perception, and self-referential processing can be transformed through contemplative practice. Some researchers suggest that certain meditative states might represent modes of consciousness that perceive reality more directly, with fewer conceptual filters and less distortion from habitual patterns of thought and perception. The neuroscientist Francisco Varela proposed an approach called neurophenomenology, which combines rigorous scientific study of the brain with disciplined first-person investigation of conscious experience. Rather than trying to reduce consciousness to neural activity, Varela suggested that both objective and subjective approaches are necessary for a complete understanding of mind. Perhaps this integration of perspectives offers a methodological bridge across the apparent divide between physical and experiential aspects of reality, as your awareness rests in this moment, neither grasping at thoughts nor pushing them away. Notice the spacious quality of consciousness itself. This awareness that knows your experience isn't contained by the boundaries of your physical body. It has no shape, no size, no location in three-dimensional space. Yet it is undeniably present, undeniably real. Perhaps this boundless quality of awareness offers a glimpse, a taste of what it might mean to transcend the limitations of three-dimensional perception. The philosopher Immanuel Kant distinguished between phenomena, things as they appear to us, and noumena, things as they are in themselves. He suggested that we never perceive reality directly, but only as filtered through the structures of our consciousness. Space and time, in Kant's view, are not objective features of reality, but forms of intuition imposed by our minds on our experience. While modern science has moved beyond many aspects of Kant's specific framework, His insight that our perception inherently structures what we experience remains profound. What if the three-dimensional space we perceive, the linear time we experience, the clear separation between subject and object that characterizes our ordinary consciousness, what if these represent not ultimate reality, but the particular mode of perception of human consciousness? What if other modes of consciousness might perceive additional dimensions, different temporal structures, more fluid boundaries between self and world? Some philosophers of mind, like David Chalmers, have suggested that consciousness might be fundamental rather than emergent, a basic feature of reality, rather than something that arises solely from physical processes. In this panpsychist view, consciousness in some form might be present throughout reality, with human consciousness representing a particularly complex and self-reflective instance of a more universal phenomenon. Perhaps consciousness itself connects to dimensions beyond our ordinary perception, dimensions that our particular mode of awareness typically filters out, but that might become accessible through altered states or contemplative practices as night deepens into its final hours. As stars begin their subtle shift toward dawn, we find ourselves returning to where we began, to the mystery of existence itself. Perhaps we are not just living in space-time, but dreaming within it, participants in a reality far more vast and interconnected than our ordinary perception reveals. This poetic suggestion brings us full circle in our contemplation of dimensions beyond perception, inviting us to hold both scientific understanding and direct experience in a unified awareness that transcends their apparent separation. Ancient wisdom traditions across cultures have suggested variations of this idea that what we experience as material reality might be compared to a dream or illusion, not in the sense of being unreal, but in the sense of being a limited perception of something more fundamental. The Hindu concept of Maya, often translated as illusion, suggests that the world we perceive through our senses is not ultimate reality, but a veil obscuring a more fundamental truth. Buddhist emptiness, shunyata, points to the lack of inherent, independent existence in all phenomena. The Taoist concept of the uncarved blokpu points to an undifferentiated reality prior to the conceptual divisions we impose upon experience. These philosophical perspectives don't deny the existence of the world we experience, but suggest that its apparent solidity and separateness may be less fundamental than they seem. Modern physics offers surprising parallels to these ancient insights. Quantum theory reveals that the apparent solidity of matter dissolves at the smallest scales into probability waves, into patterns of information, into relationships rather than things. Relativity shows that space and time are not absolute but relative to the observer's frame of reference. These scientific discoveries don't invalidate our everyday experience, but suggest that it represents a particular perspective on a reality that might be far more fluid and interconnected than our senses indicate. The philosopher Alan Watts often used the metaphor of a dream to illustrate this perspective. In a dream, we experience a world that seems solid and real, with its own internal logic and consistent physics. Only upon awakening do we realize that the entire dream world was a creation of our own mind. Yet even while dreaming, the dream objects weren't exactly unreal. They were real experiences, real patterns of mental activity, just not what they appeared to be from within the dream perspective. Similarly, our waking reality might be real in the sense of being consistent, patterned experience, while simultaneously being not quite what it appears to be from our limited perspective. The solid objects we perceive might be more accurately described as patterns of energy, as probability distributions, as information structures in a cosmic field of potential. The separate self we experience might be more accurately understood as a process within a unified field of consciousness, temporarily identifying with a particular viewpoint, but not ultimately separate from the whole. This perspective doesn't diminish the beauty or significance of our human experience, but enriches it, inviting a sense of wonder and openness. We need not have definitive answers to appreciate the beauty of the questions, to sense our connection to a cosmos that might be far more complex and interconnected than our everyday perception reveals. The physicist Niels Bohr, contemplating the strange implications of quantum mechanics, noted, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." Perhaps the same could be said of reality itself. If our understanding of existence hasn't filled us with wonder and a sense of mystery, perhaps we haven't yet grasped its true nature. Not because reality is obscure or incomprehensible, but because it might be far more vast, more multidimensional, more intricate than our everyday perception reveals. As dawn approaches and our journey together comes to a close, consider how the questions we've explored tonight might influence your perception of everyday reality. The coffee cup on your table, seemingly so solid and certain, consists mostly of empty space at the atomic level. Its apparent solidity, created by electromagnetic forces rather than actual material stuff. The clear distinction between you and your environment dissolves at the quantum level into a complex interchange of energy and information, with no clear boundary where you end and world begins. The flowing present moment. Your experience of now might be one slice of a multidimensional reality where time operates differently than our linear perception suggests. These scientific and philosophical possibilities don't require belief or certainty. They invite contemplation, wonder, openness to mystery. They remind us that our understanding of reality is always provisional, always evolving, always partial. The cosmos we inhabit contains depths and dimensions that our current science glimpses but does not fully comprehend, that our philosophies point toward but cannot completely articulate. The beauty of this cosmic perspective lies not in providing final answers, but in opening us to deeper questions, to a sense of wonder that transcends both scientific certainty and religious dogma. In the words of the physicist Richard Feynman, "I think it's much more interesting to live not knowing than to have answers which might be wrong. I don't feel frightened by not knowing things, by being lost in a mysterious universe without any purpose, which is the way it really is, as far as I can tell." This comfort with mystery, this ability to rest in wonder rather than grasping for premature certainty, might itself be a glimpse of what it means to perceive beyond our three-dimensional limitations. Perhaps true understanding comes not from accumulating more information, but from allowing our consciousness to rest in its natural spaciousness, embracing both knowledge and uncertainty in awareness that transcends their apparent opposition. As you prepare for sleep, or perhaps continue your night in quiet contemplation, remember that your consciousness, your very existence, might be connected in ways both subtle and profound to dimensions beyond the three we navigate in our waking lives. The boundaries between dreaming and waking, between self and world, between present and past, might be more permeable, more fluid than they appear in the light of day. The cosmologist Carl Sagan once noted that we are a way for the cosmos to know itself. Perhaps our consciousness, with its capacity for wonder and self-reflection, represents the universe's own evolution towards self. Through our questioning, our exploration, our contemplation, the cosmos itself might be awakening to its own multidimensional nature. Our confusion and uncertainty, our moments of clarity and insight, our dreams and theories all might be aspects of a cosmic process of self-discovery. Unfolding across dimensions we are only beginning to glimpse as you rest now in the gentle embrace of night, feeling the weight of your body against the surface, supporting it, aware of your breathing, aware of the space of consciousness in which all experience appears. Remember that you participate in this cosmic mystery, not as a separate observer, but as an essential expression of its unfolding. Your questions, your wonder, your very awareness are not separate from the reality you contemplate, but integral to its evolution and self-discovery. The stars will shine long after we are gone, their light crossing endless space. But tonight, they shine here with you in silence. The ancient photons completing journeys of millions of years arrive precisely at this moment to enter your awareness, creating a connection across both space and time that transcends our conventional understanding of separation. May your evening be calm and your rest be deep, cradled in the gentle mystery of a universe whose full dimensions may forever exceed our understanding, yet whose beauty and wonder are available to us in each moment of awareness. Rest now in the embrace of cosmic possibility.